Right, this is the chapter 3 practice test before we started. What you get looks something like this. And it has the original table I have and the new transformation done, as well as transforming a single point or your regular figure. So we'll get to that later. All the various functions, all that stuff is changing. So describe the transformation of the following. If it's the square of negative x, then we're looking for negative x. If you look at my chart on the inside, you will have to see the square root or absolute value of the different point across the y-axis. Reflection. Across the y-axis. That's equal to make sure it's the y-axis. It goes outside the square root, and it'll be across the x-axis, it's that side. The next one, write the equation for the following graph. Well, first off, we know it's a parabola. If you need to look at your parabola parent function, and I hope you can see it goes through. So the parent function goes to that point, and the next one is up here, but it's also graphs. We don't talk much about that. So it looks like they just took these, and each one of those went from 1 going up 1 to up 2. So going from up 1 all the way to up 2, up 1 all the way up 2. So that means this one's definitely a stretch. It's stretched from 1 to 2. That's the only thing that we have that doesn't move the whole graph, that then those points would go up to. So it's quadratic. And it is a stretch by 2. You're multiplying, again, it went from going up 1 to going up 2. So multiply that by 2. It doesn't go left or right any, doesn't go up or down any, so that is your answer for this one. The transformation comparative function. 2, you can either use this big table or you can use but inside to the right plus 7. Remember, that is 2 different transformations. The 3 is a vertical stretch by a factor of 3. Minus sign in front, the negative. Across the x-axis. Number in front, that is a vertical compression since it's less than 1. So this was a stretch because it's bigger than 1. This is a compression because it's smaller than 1. So vertical compression by a factor of 1/2. So the next one, this one says make sure you do order. And again, if you don't remember, this is the order you do it in. So everything in between these dotted lines is what you do first. Down is last. So in here comes first, so that is right. Then 3 in the minus, doesn't matter which order you go in for that one. So that is a vertical stretch by a factor of 3. The negative is a reflection across the x-axis since it's in front. And then the last thing is the 10 up 10. And that is the proper order for that. So moving on, the next one say write the equation that satisfies the following conditions, starting with the parent function. So we're writing equation x squared, and then go you need to use that I gave you to squared. A lot of people don't f of x is y is equal to value and say vertical stretch by a factor of 2. So it's 2 the absolute value of factor 2 reflected across the x-axis. So reflected across the x up front with that 2. We don't have anything with the absolute value, or sorry, we don't have anything inside the absolute value with the x because we're not moving left or right any, not moving up or down any, so there's nothing at the end. So that is your answer. Of x reflected is in or that is outside. And that's one of the very few times that it talks about. And that's very typical what will be on the test, where it doesn't crazy, not complicated, just make sure you know where that goes. So moving on, for each transformation listed below, start with the point -2, 8, and then find out where it will be after the given transformation. Three. So don't remember what I forget all the time. This is the table that we're going to use right here. So when you go left and right, up and down, so 3, so to the left 3 is this one right here. And so it's saying we subtract whatever number that is, we subtract from. You can see it better. So moving 3, we're subtracting 3 from the x value. One step at a time. The x value, I subtract 3. And 3 is -5, so we have -5/8. Answer yet, that's just 3. Now we have to go to 4. So again, if you look down, is this one. We subtract it from the y value. Subtract from the y value, so now it's -5. 8 minus 4 is +4. That then is your answer. Now, a lot of people have been getting confused with these, and I don't actually know why, because don't make it is if you do one step at a time. Order doesn't matter for this one. I mean, it probably does, but I'm not going to be finicky with that. So this 1/2 is a vertical compress by 1/2. So I start with -2, 8. Cheat sheet, vertical stretch or compression, doesn't matter. We do the same thing. We multiply by the y value. So we take that y value multiplied by 1/2. So I multiply this by 1/2. So -2 doesn't change. 8 times 1/2 is 4. So your answer is -2/4. So again, if you use that table as a guide, it shouldn't be too bad for those. The next one, we're graphing the following. Remember to start with the parent function. So x to the third is the parent function we're starting with. So it goes through these 3 points. Those are the 3 points we're focused on. So that's what we're going to start with. By 3 on this one, but I'm going to go in 2 steps. So right 3 is over to the right. 1, 2, 3. 1, 2, 3, and 1, 2, 3. Once you moved it, we can get rid of the original ones we started with. You don't have to, but if it makes it less confusing, you totally can. And then down 2, we just move all those down. 1, 2, 1, 2, 1, 2. Again, if you erase your original ones, you can. And then the biggest thing, once you have this, make sure you remember what it actually looks like, what this parent function looked like, that little squiggly. And make sure you do roughly the same thing. It doesn't have to be exact, but you can't be a straight line. Oops. So this is another one where the negative's inside with the x. So again, that's the other one that is reflected across the y-axis. And again, it's not anything terrible. There are not a lot of steps to it. This is the only one. So the square root goes through these ordered pairs. And again, you'll have that list. And this was reflected across the y-axis. So this point right here is 4 steps away from that y-axis. So we need 1, 2, 3, 4 steps on the other side. This one right here is 1 step away, so we need 1 step on the other side. And this one's right on, so it doesn't change at all. So that one goes to the left. That's all there is to that one. We have a quadratic. Hopefully, I have the quadratic number ordered pairs we're going to use. So jot those down quick. And then this one we go to the right 3, and then the negative out here is reflected across the x-axis. So I'm going to go to the right 3, so every one of these goes 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2, 3. Again, to make this a little less confusing, I'm going to take, erase one of my points. I'm going to take those out. And now I'm going all these across the x-axis. So again, this one is 4 steps away, so I need 4 steps away on the other side. This is the x-axis. 1, 2, 3, 4. This one is 1 step away, so 1 step away on the other side. This one is right on, so it stays right on. Can't reflect that all. This one's 1 step away, and then the next one again is 4, so this ends up being our graph. Right, the equation of this one, this is an absolute value, so there's a couple different ways you could write this. I know the parent function absolute value of x, and it goes to the left 3, so I know it's going to be x plus 3. Now, since it opens downward, you can say it's reflected across, so it's a negative. The other way you can do it, remember what we talked about earlier, where that number in front is the slope. So it's down 1 over 1 to the right, down 1 over 1. So negative 1 over 1 is negative 1. We did it both ways. So this is the other one that we're going to be able to use that we talked about earlier. This one down here. I say, and that's what I mean. Let's clean this up a little bit. This irregular function, it's not a parent function. So we just start with this one. So the first thing we do is we need to make sure I just put all these points just like it would do if it was a parent function. I put it on my graph that I'm working with. Oops, go over a little bit. So those are these corner points. That's really all I use that for. And then it says the transformation is +2, so that's left 2 and down 4. And so every one of these, left 2, and I go down 4. So left 2 is 1, 2. Left 2 is 1, 2. And 1, 2. I messed this up on the answer key. Hopefully I've updated it by the time you watch this, but if not, right. I even said to the left and still went to the right. So, and then down 4, 1, 2, 3, 4. 1, 2, 3, 4, and 1, 2, 3, 4. Once you have these, make sure you connect them in the right order. This one isn't too bad, but when you have a reflection, on the last quiz, a lot of people messed that up because they were connecting it in the wrong order. So they would connect to something like, we'd finally get done and say, there we go, that's my answer. So make sure you're connecting it in the right order. I've done this before, you don't have to do this. Again, this one's not too bad, but I've done 3. So then when we change, that'd be 1, 2, and 3, and this would be 1, 2, and 3. Again, you do not have to do that. That just is a good way to see what order you connect those in. So graph these. We're doing the parent function. For this one is x squared. If you need to use your cheat sheet, by all means you can. X-axis, so that is going to be down here, reflecting all those points, and then erase these, everything up to 2, 2, 2. We'll say that one does matter what order you do it in. So if you accidentally went up first and then reflected it, it might be a little bit different. Again, I'm going to be lenient on that for this one. Yours looks different than mine, that's why. Lines, oops. So this is a solid line because it's got the equal to part with it. Do we go above or so I vertex. If y is greater than, it's above the vertex, so that's up here. If that's where you're shading, you also shade that whole area, which means I'm shading outside of my my parabola. I need to shade everything on the outside. That's everything down here, everything over here, nothing inside. So if you need to, look at your vertex, shade above or below, and then just fill in everything else with that. This is an absolute value. Again, there's a couple different ways we've done this, but I'm going to stick with this part for right now. We move everything 3. So to the left 2 is 1, 2, 1, 2, 1, 2, 1, 2, and 1, 2. Move everything down 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2, 3. I'm going to get rid of this mess because that is confusing. That's solely for your benefit. And this is a dotted, so dotted. And remember, if you ever want to, you could make it solid and just label it dotted. That's we shade it above or below. Well, again, below, so my vertex is right here, so below is over here, so it ends up being outside my graph, outside my absolute value for this. So now we're going to graph, and this looks like, I mean, honestly, this first one isn't too bad, but we're getting into where we're graphing the absolute values like we did in the very last lesson. So way before we got to the last lesson, so this first way is actually, wait first. The way we did this in the last lesson is we would go to the left. So we'd start here, 1, 2, 3, 4, 5, down 1, 2. 3 over 1 to the right, up 1, 2, 3 over 1 to the right. Inside to get the left side, use do that slope. 3 over 1 to the right, I go up 3 over 1 to your left. The other way to look at it, those tree. But again, remember, we can do it the same way we did all these other ones for this one. The next one might be a little, but you can start with your parent function, down 2, left 1, 2, 3, 4, 5, down 1, 2, 1, 2, 3, 4, 5, down 1, 2, 1, 2, 3, 4, 5, down 1, 2, 1, 2, 3, 4, 5, down 2, and left 1, 2, 3, 4, 5, down 1, 2. We are multiplying it by, we're stretching it by a factor of 3. Okay. The reason this messed up, let me do this real quick. So everything's fine. The order matters. Order does. We have to stretch first before we go down 2. By 3. All the heights by 3. So instead of multiply by 3 and go 3 to go 6. The next one, we go up 3, and the next one we go up 6. So thing we do is 1, 2. Again, it's kind of obvious that the order matters, but again, if it were me, if it's an absolute, I call this the slope rather than the stretch or compression, because that's going to, I think that's the easier way to do it. Especially for this one, when your compression is 3 over 4. That's a pretty complicated one. So we start at 0. I don't go left or right any, but I do go down 2. And then my slope from there is up 1, 2, 3 over 1, 2, 3, 4, up 1, 2, 3 over 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4 to the other side. 1, 2, 3, 1, 2, 3, 4 to the other side. And that ends up being your graph. These next ones are, oh, I thought they were both inequality. So the first one's not an inequality. So again, we're going to start at 0. And again, you could do this one the other way where you start with the parent function, but just remember the order. And I know earlier I said that I'm not super finicky, and I'm not. So if you honestly do it that way, that's probably okay. Easier to do it the way we ended the very last section, that 3.5. We go to the left one, up 1, 3, 4. Then from there, our over 1, down 2 over 1, and then the same thing to the other left, down 2 over 1 to your left. Moving on to the next one, and again, you can see like these are pretty complicated ones. Information's in this. 1, vertical stretch by 2, reflected across the x-axis and up 4. There's 4 different things you do. It makes it pretty easy when you do it that way, when you look at that as a slope. Granted, we can only do this with absolute values, but that's okay. So start at 0. This is equality. Be careful of that. So this is going to be dotted. And there's going to need shading for this one, so don't forget that. So we go to the right, 3, up 2. So 1, 2, 3, up 1, 2. And there our slope is 1/2, so -1 over 1, 2, down 1 over 2. And you have to do the same thing to the other side. Now is where it is dotted. And again, I'm not very good at making it dotted, especially on this. So if you want to just label it dotted, you can. Your job. Try to be a professional. If you shade on, again, you can look at span. So we shade, this is the vertex, we shade below that vertex, which means we shade everything in that area or everything on that side. Since it's inside, shade everything on the inside. The next one, what's the equation of this graph? Well, again, we know it's an absolute value. So on an absolute value, we start here and we went to the left, 1, 2, 3, 4. So it's going to be plus 4 since we went to the left. And I go up 1, 2, 3, my new vertex. So that's plus 3. Once you have that, then just find the slope. So it looks like it goes through this point really nicely. So down 2 over 1. If you want to double check yourself, just do it a couple more times. Down 2 over 1, down 2 over 1, down 2 over 1. Yeah, so that looks like it. Down 2 over 1, which ends up being -2. So y is equal to -2, absolute value x plus 4, plus 3. So that's the last one. I will try when I'm discussing the test, or maybe I will try to put a hint in there to make sure you realize these are absolute values so you can graph them that way using that shortcut. But again, technically, any absolute value on this test, you could graph that way. You do not have to do it using transformations. The other ones you kind of have to, but for absolute values, you don't, since we taught you that other way. So if you have any questions, make sure you let me know. Thanks.